Right, today we're going to talk about a section that's not in the book, the law of sines and the law of cosines. For this lesson, we're going to be talking about finding missing sides and angles in triangles that are not right triangles. So we cannot use SOHCAHTOA. So first off, the law of sines, which is up here, says that we take the sine of angle A divided by the side that is opposite angle A. And that's equal to the same thing for sine of angle B over the side of B. So in this triangle we have the angle A opposite the side of A, and so that's how we would set up that ratio and then set up an equal proportion. We are going to use the law of sines when we are given angle, angle, side, angle. But we have enough information to set up the proper proportion. How would that look in the, actually, let me back up here. First, one of the things we'd like you to do for tomorrow is prove that the law of sines works for any acute triangle. So you can draw in an altitude and work on that proof for tomorrow. Now, as far as solving the triangle, first off, we should draw the triangle and see what we have. So when we put in the given information, we see that we have angle, angle, side, which is going to tell us that we are going to do the law of sines. We need to solve for a few things here. We need to find angle B. We need to find side B and side C. We are typically going to round the angles to the nearest degree and sides to the nearest tenth. But in this case, we're going to round the angle to the nearest tenth only because that's what our given information has. So we can easily find angle B by knowing that this angle is in a triangle out to 180. So we can find the missing angle in this case is 56.2 degrees. Now bringing in the law of sines, we can take our information on the sine of angle A, 72.3 degrees, divided by side 40 is equal to, and then we can pick whichever side we want to solve for first. If we pick angle C, sine of 51.5 over the side opposite, which we'll call side C. Now that we have our proportion set up, we're just going to cross multiply. So we can get that side C times the sine of 72.3 is equal to 40 times the sine of 51.5. So we'll type that into our calculator. 40 times the sine of 51.5, and we are going to be dividing that by the sine of 72.3. We get an answer of 32.86, which we can round to 32.9. Now we're going to do the exact same process for side B. So in this case, we still can use the information we had from A, sine of 72.3 over 40, but in this case, set it equal to B and the side opposite, so sine of 56.2 over side B. We cross multiply. So in this case, we're going to type in 40 times the sine of 56.2, and make sure we close the parentheses if you're going to divide all of it at the same time, and divide that by sine of 72.3. We get 34.89, which we can round to 34.9. So now we have solved the triangle, we found the missing sides. You can do the same thing for number 2. First off, draw the triangle. So in this case, we are solving for angle B, we're solving for side B, and we are solving for side A. So for this one, our first ratio that we have, we can set up the sine of 62 divided by 4.5. And then when we are solving for side A, we can do the sine of 66 divided by the side of A. And then we could do a completely separate one for side B. First off, we need to find the measure of angle B, which, using all angles out of 180, we can say is 52 degrees. So our one ratio that we have is sine of 62 over 4.5, and then set that equal to, for B, the angle is 52 over the side of B. So go ahead and pause the video and finish that one by solving for side A and side B. Once you plug those in, you should get 4 for side B and 4.7 for side A. The next one is the law of cosines, and we have to use this one when we are given different information. And one of the first ones is side, side, side. If we look at the first triangle that we're given here, we have side is 4, side is 5, and side is 6. So we can see here that we need to find angle A, angle B, and angle C. The issue is the law of sines won't work here, because if we took the sine of angle B, we don't know it, over 5, equaled the sine of angle C over 6, we don't know either one of those angles. So we have two unknowns in there. So we're going to use a different law. In this case, it's the law of cosines. The formula is up top there, and when we are doing the law of cosines, the first thing that we have to know is that we must solve for the largest angle first. Once we get the largest angle, we will then have enough information to go back and use the law of sines, which we just did a problem with. So then we will solve for the smallest angle using the law of sines. Now that we have two of the angles, we can go back in and know that the sum triangle is 180 degrees. So let's go ahead and work on the third problem here. So when we're solving this one, we need to plug in, and going back to the formula here, this the C can be substituted for different letters. This is just those that side and the angle opposite it, and these are the other two sides of the triangle. So those letters could be reversed if needed. So in this case, solving for the largest angle would be angle C. So then I'm going to plug in the information from the triangle using that formula. It's going to look like 6 squared equals 4 squared plus 5 squared minus 2 times 4 is 5 times the cosine of angle C, which we don't know, and that's the one we're finding. So once we plug all the numbers in, which is just looking at the formula and plugging them in, we then need to simplify this. So when we had 4 squared and 25 squared, we're going to get 41. And we're going to subtract the 41 over to the other side. And now we can divide by negative 40, and we can find that 0.125 equals the cosine of angle C. We talked about this the other day about finding the measure of an angle. We have to take the inverse cosine. So we're going to type in the inverse cosine of 0.125 in order to find the measure of the angle. Find out that the measure of the angle is 82.8 degrees, which we can round to 83 degrees. We now have enough information to find another angle. We can use the law of sines now to find the smallest angle. So now when we set this one up, we can say that the sine of 83 over 6 is equal to, in this case, the smallest angle would have to be A because it is opposite the smallest side, so sine of angle A over 4. Now, when we actually type it in, we don't want to use 83. We want to use the number that is on our calculator. So we're going to take 4 times the sine of our previous answer, which is second answer. 4 times the sine of our answer. And then we want to divide that by 6. Remember, that's what the sine of angle A equals. So in order to, our sine of angle A is equal to 0.66, etc. In order to find angle A, we need to take the inverse of that sine of the answer and find out that angle A is 41.4, or roughly 41 degrees. And then we can find the missing side, and I put that in the wrong spots. And then we can find the missing side by using the sum of the angles on a triangle is 56 degrees. Now the last case is going to be, and that should be an angle, a degree. So then for number 4 we can draw the triangle, A, B, C, put in the information that we have. And in this case it's just a little bit different. We're given side, angle, side. So the process in order to solve for side, angle, side. In this case we need to solve for the side using the law of cosines. And then we can go back and use the law of sines because we'll have enough information. And we're going to solve for the largest angle left using the law of sines. And then again the sum of a triangle equals 180 degrees. So when we plug in this information, we get that A squared is equal to 50 squared plus 42 squared minus 2 times 50, 42 cosine of 40. That you can just type into your calculator the way you see it, as long as you use the parentheses. And we get that A squared is roughly 1046.61. We take the square root of that, and we get that A is 32.35, which is roughly 32.4. We now have enough information to use the law of sines. So sine of 40 is the degree over 32.4 equals the sine of angle C over 50. Remember, when you take the sine of 40 divided by 32.4 right here, we need to make sure that we 50 times the sine of 40 we need to make sure that we divide by that entire answer of 32.4 when you take the square root of that number, so that you're not rounding. So go ahead and finish that problem for tomorrow.